So if I have two vectors, v and w, and say I want to find the angle between the two, oops. And of course, we have to stick to the traditional initial side, terminal side, and all that stuff. It comes from a dot product, which we can write it in a different way using the magnitude. The magnitude of the vector v multiplied by the magnitude of the vector w multiplied by cosine theta. If I divide both sides by magnitude of v times the magnitude of w, I will simply have cosine theta. If I have cosine theta equal to something, I can easily find theta by using arc cosine, or excuse me, or cosine inverse. So let's say we have two vectors. So 2,5 or 2, 5, minus 1, 3. We graph it. Okay. um, 2, 5 would be the vector right here. Negative 1, 3 will be right there. That's V. Well, that will do. And that is the angle we would have between V and W. How do we find? Well, first we've got to find the magnitude of V and the magnitude of W. And of course, the dot product. First, we want to find the dot product. Flip the first vector. So 2 times negative 1 plus 5 times 3. Negative 2 plus 15. We get 13. we want to find the magnitude of V, which is simply the square root of the square of each term, each component, I should say. 2 squared plus 5 squared, square root of 29. If you approximate it, be 5.39. The magnitude of W minus 1 squared plus 3 squared, square root of 10. And if you approximate it, you'll get 3.16. Now that we have the dot product, the magnitude of V and W, we can easily find cosine theta. Cosine theta is simply the dot product divided by magnitude of V times the magnitude of W. So 13 over 5.39 times 3.16. I'm getting 0.7632. So an easier way to check your answer, when you get the result here, it cannot go over 1, it can't go below -1, because whatever answer you have corresponds to cosine theta. And cosine doesn't produce a value above 1 or below -1. So theta will be cosine inverse of 0.7632. If you put it in the calculator in radians mode, you should get 0.7025. If you put it in degrees mode, I'm getting an angle of 40.25 degrees. You know, we have to write it in terms of degrees, minutes, and seconds. I'm not going to get into all that now. I'll just call it 40, excuse me, 40.25. Poorly drawn graph, but you see 2 vectors. One, excuse me, one is 2, 2. The other is 2, -2. The angle between the two is theta. We can guess that angle even before we start the problem. I intentionally used a curve to represent theta rather than put the regular right angle sign, because if I'd drawn the right angle sign, you would know the exact answer. I wanted you to make a guess first. So we have 2 vectors, 2, 2, 2, -2. I want to find the angle between the 2 vectors, which we know is the dot product of V and W divided by the magnitude of V multiplied by the magnitude of W. If you get the dot product to be 0, in other words, if the numerator becomes 0, zero divided by anything, still 0. Cosine theta becomes 0. So I'm going to find the dot product. Two and 2 minus 2. So 2 times 2. 2 times minus 2. 4 minus 4. I get 0. As I mentioned, if the numerator is 0, that's what we care about. Because anything divided by 0, any valid number divided by 0 is 0. Did I say it backwards? I think so. Any number, 0 divided by any number is 0. So theta will be cosine inverse of 0. Cosine inverse of 0 is pi over 2, or 90 degrees. So the vector V are at a right angle. So if two vectors are at a right angle, then they are called orthogonal vectors. Naturally, orthogonal vectors will have a dot product of 0. We get an angle of 90 degrees because the dot product is 0, so they go hand in hand. So if two vectors are at a 90-degree angle, then they are orthogonal to each other. There are reasons as to why we need orthogonal vectors. It's used in, upper level math. As I said, the entire concept of vectors was introduced to extend what we see in lower dimensions to higher dimensions more than 3. You can take any vector or two vectors and you can turn them into orthogonal vectors. we're not going to do that in this class. It's a bit advanced. So it can be done, but we're not going to do it. Are the unit vectors I vector and j vector orthogonal to each other? The answer is yes. Reason, well, the I vector is the unit vector along the x-axis. Oops. J vector, unit vector along the y-axis. And just by looking at it, they are at a 90-degree angle. So they are orthogonal to each other. This applies to any unit vector, the basic ones I, j, k, and in higher dimensions. They're always orthogonal.